So for today, it's about reflections of exponentials. First off, you got to understand this is an exponential. It's a very typical one. That blue one right there. The one that is a reflection of it is this black one. Now, do you get that one of those is growth and one of those is decay? The blue one's growth, the black one's decay. But they also are a reflection of each other. All right, so let's talk about that for a second. So what if we had y equals a normal exponential would look like this, and when you reflect it, you flip it like the black one and the blue one are? Did that get reflected up, down, or left, right? The blue one to the black one, did that go up, down, or left, right? That one left, right. The blue one to the black one, they switched this way. They spun around. The blue one spun around and became the black one. So how do I get it to reflect left, right? Well, that's a horizontal thing. That's on the inside. So if you put a negative right there, it flips the graph around backwards. All right, what if I put a negative in front? Well, on that would flip it the other way. So here's what a normal exponential looks like. Here's me flipping it upside down, up, down. See the blue one? See how it's flipped upside down? That's a vertical flip. That'd be like this flip happening. The kind where it goes left, right, that'd be like this. When it flips this way, that's horizontal. That'd be like this one. Oh, so by the end of the lesson, I'll be able to describe and graph reflected exponential graphs using the rules of transformations from semester 1. By the end of the lesson, I'll be able to transform all exponentials using translations and reflections. Okay, so basically moving things around and flipping. All right. That's either on the inside, that negative, right here. That negative in there, that's either on the inside or it's on the outside. I'd like you to write down horizontal or vertical underneath each graph. Sorry. Write down horizontal or vertical underneath each one. You can put an H or a V. That'd be fine. Quinn, first one, what do you say? I agree. It's horizontal because it's on the inside. So that's high, horizontal inside. That's a horizontal reflect then. And what do you say about the next one? Vertical. So vertical on the outside. Okay, you gotta put, thank you, you gotta stay with me here. All right, so next one is inside or outside? Lewinsky, what do you say?
Outside.
It is not on the outside. It's a very classic mistake. You see those parentheses and you think it's outside of the parentheses. Nope. It's inside with the X. So trying to get this straight in your head. If it's inside, it's in there with the X. Do you see that negative is in with the X? If it had been on the outside, Jack, it would have been here. That red mark, that would be on the outside. I know you might feel like it's outside the parentheses though, but there's two spots it can be. Up in the exponent with the X, that's inside. It'd be inside. And this, outside. Why does it matter so much? Because it's a totally different kind of flip. Again, if I had a normal graph, it'll either flip up and down or it'll flip left and right. All right, so Cameron, this last one, inside or outside? Yep. So is it horizontal or vertical? Horizontal, inside. Vertical, outside. So which one is it again? It's vertical. It's a VO. Vertical outside. So that's a vertical flip. But you know, all it really matters. Like I was just telling one of my colleagues today in the math office, I said, kids can even forget which one it is as long as they can make the XY chart right. Because if you graph the points and it goes dot, 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 and you're like, oh, I thought it was going to reflect this way, but actually the dots are here, you'll be able to connect the dots. It's just, will you screw up the dots? So everybody right now, take that last one and make an XY chart for me. I want you to put in 0 and 1 and -1 and write down the answers. If you're not careful with your negatives, that's the thing that'll cost you the A or a B this time, and you end up with a C. If you're not careful with these negatives and where they flip things, and that numbers have to come out negative at the right times. Okay, Alban, you stuck in 0, and you had negative on the outside, 1/2 to the 0. I'm warning you, this is a tricky one. So think it through. Don't just automatically give a quick, super quick answer. Do you feel like you know what number it is? And then whether or not it's negative is a different thing. What number do you think the answer is? I agree, it's 1. Now is the question, is it -1 or is it regular 1? It is -1. Now, I could have easily seen kids mess that one up. I get it. You would have thought, but it's -1/2 to the 0. No, it's not. It's 1/2 to the 0. It's 1/2 to the 0. That negative is clearly separated off. It's outside of a parenthesis. That negative is not on the 1/2. So that 1/2 gets put to the 0. And that is one of the trickiest things right there. Because if you screw that up, your graph's not going to look right. All right. Veda, the next one, you put in a 1. That's probably too easy for you, Veda. But tell me, what do you think? It is -1/2. Very nice. All right. And Vikram, the last one. When you put it to the -1 power, do you remember what that does? It flips it. Does it also make it negative, or does it just flip it? Just flips it. Good. So what do you think the answer is? Yes, except where'd the negative go? Just think that through now. Do you get, it was going to be negative, or it was going to be 2, but there's a negative on the outside, so -2. That negative in the power doesn't change the negativeness of the number underneath it. A negative in the power never makes the answer negative. So the only reason it's negative is because there was a negative out here. Now I totally get, if I had just said do this one quick, a lot of kids would have had 1 or 2 of these wrong, and that's what's going to get you on the test, is not being careful with those. All right. I'm going to do one more like that. Y equals -2 to the x. And notice I'm going to put a parenthesis right here, just like last time. Now you be careful with them this time. And I'd like you to put in 0, 1, -1, and +2. If you can graph those 4 points, it won't matter if you screw up, oh, the negative was on the outside or the negative is on the inside. If you can do the points right, everybody can graph points, everybody can connect dots, you'll be able to get the graphing problems right. Mr. Null, put in a 0 carefully and tell me what you think the answer is. It is -1. Very nice. Because this part was 1. And then they slapped the negative on it later. Okay. Next up, Alban, put a 1 in there and tell me what you get. -2 is correct. Oh, let's see. Who haven't I tortured yet? Bennett, how about the negative 1? When you put that in, what do you get? Yes. And Joey, last one. Put in the 2. It is -4. Very good. Do you get that the negative part of this, if I put it in with the 2, almost every one of these answers would be different? If I put the negative in there, inside the parenthesis, almost everything would be different. Let's do one like that. Y equals parentheses -3 to the x. And then I'd like you to make an XY chart. I'm telling you, if you can do this, you're halfway there. This is why we got to practice this so much. If you can do this, you're pretty much ready for the test. Natalie, 0, 1, -1. Tell me which one you want to do. I don't care. Whatever you're comfortable with. Okay. In this case, you put a 0 right here. What do you think the answer is? +1. Very good. It's going to be different because the negative last time was on the outside. All right. Amelia, put in the 1. -3 to the 1 is -3. Very nice. And Dylan Nault, the last one. Put in -1. -1/3. You got it. All right. Now, do you remember I told you guys where the asymptote was? It's whatever's out here. But there's nothing out there. Well, then you could say there's a 0 out there, so the asymptote would be y equals 0. Do you remember that part? The asymptote's the number on the outside. So if I give you one like this, y equals 2 to the x plus 4, I move the whole graph up 4. The asymptote has to be moved up 4. So the asymptote isn't at y equals 0 anymore. It would be where? Y equals 4. So knowing where that asymptote is huge. Because if I draw a line like this on the graph and I put in my dotted line asymptote, it's like, okay, well, I know my graph's going to stay on one side or the other of that because you can't touch those asymptote lines. It like puts up a fence. And then if I graph like three dots, dot, 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 then I'm like, oh, it's got to be here because you know where the asymptote line is. So knowing where the asymptote line is huge. So one more like that. Y equals negative parentheses x 2, nope, I'm wrong. Sorry, not x there. 4 there to the x plus 3. Where's the asymptote? Studansky, where's the asymptote? Yep, y equals 3 is the asymptote. And then you make some dots, and then it'll be easy. Jack Lewinsky, tell me one thing that would be logical to put in, because we're not going to make you use certain numbers. What do you think we should use? 0. I agree. And when you do that, carefully, what do you think the answer is? And tell me, walk me through it in case the kid is like, what did you just do there? That'd be a 1. That makes it -1. That makes it 2. 0, 2. Boom. Nice job. Pick another thing to put in there. Quinn. All right, we'll put in a 1. 1 goes there. 4 to the 1 is 4. Then you make it negative. -4. -4 plus 3. -1. All right. So let's move on to the next page. There's your job. Typical test question. Can you graph that? We just practiced it. Something very similar to that, but now there's a negative in front of the x. Remember, figure out where the asymptote line is. That'd be huge. Then find a few points, and then it's easy. All right, when I call your name, please say here. Natalie, Ashlyn, Matilda. Last call for Matilda Bach. Okay, today is the 20th. Imagine it's the test. And if you just did this really quick, you might have gone, okay, I know that this kind of looks like this because it's exponential. But then it's a flip. So I kind of know that that's, is it a vertical on the outside flip? Oh, no, that's an inside flip. So it should sort of look like that. See that pink line? It should sort of look like that. Now, is it exactly like that? No, because I'm not being careful with my points. But I know it generally should be like that pink line. Kind of looks a little bit like decay. All right, so here's me putting in my first points. I put in 0, and I'd have 3 to the negative 0, which is like 3 to the 0, which is like 1. 0, comma 1, dot goes right there. So far, it kind of followed what I thought with my pink line. Next, I'm going to put in a 1. And then I got 3 to the negative 1, which is 1/3. Over 1, up 1/3. It's like there. And that, yeah, this is going down, kind of like I expected it to. I know for sure there's a plus 0 on the outside, so the y asymptote is y equals 0, whatever's out here. Oh, so I should put that in. Dotted line right on the y-axis. Last but not least, one more point. I'm going to put in 2. 3 to the negative 2. Well, that's like 3 squared, which is 9, but then you make it negative, which makes it 1/9. Now, I know some of you probably didn't do 2. You didn't have to. What if you put in negative 1? It was actually really smart, because negative 1, we get to do negative of a negative, which means basically 3 to the positive 1, which is just 3. That's a much nicer point. Negative 1 comma 3, and 2 comma 1/9. 2 comma 1/9 is like just barely above 0 here. And look at that. It's a curvy line heading down just like I kind of expected. So if your life depends on these, which I know it won't, but your grade will, take a second and decide where you think it should be and make sure that matches up. Like, I think of this as, okay, generally would have been exponential growth, which would have looked like this black line. But I know it's going to get flipped. Does that look like this black line but flipped? Oh yeah, it does. So don't just blindly trust your points, and don't just blindly trust where you think it should be. Do both. All right. One more. And then seriously, you know what? Let's not even do that one. That's too easy. Let's do this one. Everybody turn to this one. It's 1/4 to the negative x. Ella Paulson, tell me a number that would be smart to put in.
1.
Good. I put in a 1, and then it's actually negative 1. So, Lily, what do you say?
Wouldn't it be 1/4?
But it's got a negative 1 power.
So would it be negative?
Nope, negative 1 powers flip them.
So it'd be 4.
It'd be 4. 1 comma 4. There's a dot about there. You get what just happened there? I put in a 1, but there was a negative in the problem already, making this a negative 1. Negative 1s take things and flip them over. That 4 got flipped over and turned into 1/4 got flipped over and turned into a 4. Okay. Quinn, tell me another number that'd be smart to put in. 0. Negative 0, what do you think negative 0 is? It's just 0. And then anything to the 0 power, what's that? Good, 0 comma 1. Dot here, dot there. It'd be kind of nice to know where this thing is headed. Jack Lewinsky, where's the asymptote? It's always y equals something. Yeah, because there's nothing out here. So then y equals 0. So there's a dotted line right on 0. I never mind if that goes up a little bit, because then I can actually see it. If you draw it perfectly on the y-axis, it's hard to see. All right, Joey, give us one more point that you could put in this thing. I like it. If I put in -1, I have negative of -1. So again, right up here, I'd have a -1 there. So, Mr. Larson, finish it off. What's -1 turn into 1? So what's the answer?
1/4.
Yep. And -1 comma 1/4 means go over -1 and up 1/4 of the way, which is about there. Now, last thought. Does this kind of match up with what you would think? The parent graph, it seems a lot like this should be decay, which would be like this. But this has a negative on the inside, which means that it flipped it on the inside this way. Does that look like my red line was a flip like that? Yeah, that looks right to me. So you just kind of like judge at the end. Does it seem like I kind of have a logical answer? What's important there is just to like make sure that you didn't do some dumb thing with your negatives. It happens all the time. And if you check yourself, you double check yourself like that, very likely you won't get up. All right. I don't feel like we need to do too much more here. We're going to do this one in the purple box because it's been moved. Be careful. That's 7. It's up in the power. So when you put in a 1, for instance, put in a 1 right here, that's -2 to the 8. That is a huge number. It's way too big to possibly even graph. So let's use strategy. If I don't want the number to be so big, how about if I use -7? Do you get what I was thinking? I could make that power just turn into 0. So if I were you, I wouldn't pick numbers like 1, 2, and 3 because you'll get massive answers. Bennett, walk me through putting in a -7. So what does this turn into? Just the power? And then 2 to the 0 was... Your answer is -1. You're right. I'm just trying to walk people through why it's negative. Because first you did this, and it was 2 to the 0, and that was 1. And then you put the negative on it. -1. You are right. -7. -1. It'd be really nice to know where the asymptote line is. I would be a little nervous on this one that kids would think the asymptote was at 7. I get from me saying that it's not at 7. So what is the asymptote at, Joanne?
0.
Yes. So the asymptote stayed here, right on the line. I only got 1 point. It's really hard to tell where the thing's going from 1 point. Alex Stone, can you give me another number to put in? Kind of close to -7. -8. If I put in a -8, -7, or sorry, 7 and -8 makes -1. So then it's -2 to the -1, and -1's just flip things over. And it flips it over to be 1/2, but the negative doesn't go away. -1/2. Besides, if I had thought that there was a dot across this line, I would have known something was wrong. Because you can't touch that line. There can't be points on both sides of that line. So you'd have known something was wrong. -8, -2 is here. Bertha, tell me one more logical point to put in.
-6.
I was thinking the same thing. -6, because then you can make the power come out really nice. So walk me through it, Bertha. What's -6 plus the 7? All right, 2 to the 1? -2. So -6. I feel like something just went wrong. -1, 2, 3, 4, 5, 6. I know something went wrong. Ah, now this is going to happen to you guys too. You're going to look at your graph and go, I hope you wouldn't have been like just blindly going, okay, I guess it goes to parabola. These aren't parabolas. So I knew I did something wrong. I just didn't know what. I didn't know what. So Bertha, I think you caught it. Which of my points was messed up? Yeah, I graphed this one right here. I graphed it wrong. -8, -1/2. And now I realize that this -8, -1/2 should be right here. Okay. Now, all we're going to require you to do on the test is 3 points. You know it just gets closer and closer to that line, but never touches it. And there we go. Good enough. Okay. I feel like you guys could do pretty well on this. I really do. You've been following me really well, and I feel like you got this. So, if I do like too many of these in class, you won't feel like doing your homework. So, I think we should get to your homework at this point. Everybody find the homework, and I want to do the first one together. The homework is the only one that's in the 5/20 folder, today's folder. Hold on. Can't find it myself. Hold on a second here. My bad. I was in the wrong 5/20 folder. I was in there for my other class. I was really confused for a minute. Okay, it says U5L5 worksheet. Cameron, could you read me problem number 1 from the U5L5 worksheet? X equals, oh, f of x. Okay, f of x equals, and that's like y equals, 2 to the -x. Okay, good. Now, I got to graph it. Some thoughts. XY chart. Jack Lewinsky, give me a smart number to put in. I put in 0. What do you get out? Yep. And then I go to my graph, and I put 0, 1 on the graph. Okay. Quinn, what's another good logical point to put in? All right. Just a second for my Apple Pencil to connect. All right, I'm putting in 1. 1 goes here. There's so many negatives. Be really careful, Quinn. Do this part first. To 1/2. There actually isn't a negative in the answer then. It's just 1/2. So then you go graph it at over 1, up 1/2. At this point, I'm starting to wish I had the asymptote line in there. Alex Stone, look at this equation. Do you see anything on the outside of it? Then what's the asymptote equation? Yep. Y equals 0. Dotted line runs right through here. I have 2 points. I just need 1 more point. Bennett, would you please put in -1 for me and tell me what you get?
2.
Yeah, because this part becomes +1. 2 to the +1 is 2. So -1 comma 2. And there we go. And now I can draw my line. Doop-a-doop-a-doop-a-doop. That's all there is to these. It's not that bad. Just like last time, I'm going to have you skip 1C and 2C. That'll keep it doable. Problems 1C and 2C can be skipped. Okay, that's all I got for you for the video for today.